Hello, my name is Aussie Podero, and I am a Capstone 2 student for spring 2021. And I will be showing you how to install the mobile VVR application, or the mobile VVR version of the application on an iOS device. And also on an Android device, but unfortunately I don't have an Android, so I won't be able to go through all the steps, but I'll get you as far as the APK files. Right now we are in the Unity Hub environment. Here, Unity Hub is where you're going to be adding your projects or creating your projects depending on what versions you have. Currently, I have the 2019 4.20 F1 version, which is an LTS version for 2019, and the 2020 3.3 F1 version. We have built the VVR application to be Unity agnostic, meaning that you can go ahead and upgrade to different versions of Unity to take advantage of any benefits or any new features that Unity might have in their framework, so that you can advance the project. If you go to installs, you can see the actual versions of Unity that are on my computer currently, and also the build support. For this particular project, we built it in, or we did develop it in 2019 for 20 F1. So we have all these different supports and frameworks for it. You can add it via the add here button, and you can add either different versions of Unity, or from here, you can actually add different modules. Back to the project. You see I have the mobile VVR project here already. In the case that you need to add it, you just press the add button, and then you'll go to the project, locate the folders where you have the project folders located, and there you can open and select whatever project files you desire. Once here, you go ahead and double click on the mobile VVR, and the appropriate version for the VVR Unity will pop up. Once open, you can see that we are in the environment for VVR. This is the Unity editor. There's some elements here that are really important to developing this project. This is your hierarchy here. This will hold the scene. So all the elements within the scene that you might have will be here in this hierarchy here. Your asset folders would be here in this hierarchy down here, where the project folders are. And also you'll have access to the actual folders here. If you want to look at particular scripts or particular scenes, you can actually go in and double click, and it'll open up into your style of editor, whether the VS Code, Visual Studio, or Writer. In this view, you'll see you have a scene view and a game view. So the scene view is all the elements or the global elements in the scene. And the game view is the view of the camera that you're looking at, right? So it's the actual camera image that you're taking in. You can go ahead and look at different types of object properties in Expector. This will be important because here we can add scripts to add different functionalities to the actual camera. In this case, we have, or the game itself. Right here, we have a player script, which is going to create a sphere object or sphere canvas that's going to host the video node or the media that we're trying to use. Player movement is going to give you the movement within the game, so up, down, left, right when you're looking around, or when you're either moving with gyroscopic movement on your phone or the mouse lookup movement. The video manager enables you to have video functionality. It's also a way for us to go ahead and to add functions to voice commands like play, pause, and rewind and fast forward. So as you can see that there's a lot of scripts here that basically are gonna go ahead and are gonna give, they're gonna work in conjunction and in concert to enable the VVR experience. You can actually play it in the editor. So in the in this view here, and you can see that you have functionality. You can enable and disable the voice. Although the voice control in this particular version cannot be enabled in editor mode. It can only be enabled in the iOS build or the Android build. So next, we're going to go select File, Build Settings, and in here, we're going to go ahead and make sure that we have an open scene here. As you can see, this is blank. So we're going to hit this button, and it's going to give us the main scene, which matches the main title here. And we're going to make sure that we're selecting the iOS version or the iOS platform. There are two ways of going ahead and running Xcode, either release or debug. We prefer the release. You can use debug. It has to do, the difference between debug and release is that the debug will actually go ahead and register certain certain events in the debug for the iOS for in Xcode. So you'll be able to see in a verbose fashion, like what things are happening, what things are being turned on and turned off via the output of Xcode. So either or can work. I usually like release because Xcode already has a debug feature. So if you're going to be running iOS, most likely it's going to be on debug if you're using Xcode. And in that fashion, the debug by default, those files and that output registry is going to be already enabled. So once we're here, we can go to player settings. If there's any other player settings that we might want to, let me go ahead and do that again. Player settings. We can stretch this out. The things we got to make sure of is that we're on iOS. We have the version here. Even though this is version 3.0, the version for test flight, we have to keep it at 0.10. And the reason why is because if we make too many changes in the version number, test flight will not approve it quickly. So you'll have to have like a waiting period for them to review your code so they can go ahead and you can put it on test flight. The most important aspects here are to make sure that the bundle identifier is the same. In this case, OB, VVR, FIU. That's what I'm using as my bundle identifier. The build. So the build version for this one is 5. It's not. If you decide to build it on your own, you'll probably be using your own developer account. So this build number is specific to the versions of that I was using to build it to test flight, but not necessarily something that you guys need to have. You guys can start at 0 or 1 or however you wish within your account. These are some of the usage descriptions that we need. iOS needs to have a description for usage to go ahead and to give you access, since it does sandbox a lot of the hardware to use in their iOS devices. So we need to make sure that we have the appropriate descriptions for location, for the microphone, and for the camera usage. Make sure that our minimum target is at 3.13. I think due to, if we want to enable BVR, it has to be at a version higher than 11.0. I'm sorry, if you want to use like the XR camera, which is in a different scene from this one, you might want to use versions higher than 9.0. So to keep it safe, I use 13.3 because right now we're currently of version 14.4.1 for iOS. You can change this from simulator to device SDK. So device SDK means that that you'll be building with your device connected to your computer, where the simulator, you'll be using the simulator that's enabled with the Xcode. And the architecture here has to be 64, and everything else you can leave the same. So once we have those player settings ready, we go ahead and select build and run. And as you can see, I already made a Unity project with this this particular project. We save it, or you can name it whatever you want. It's going to be a little while before you start seeing the conversion. You're going to the actual Xcode. Right now, what it's actually doing is that it's converting all the files that it has, all the scripts and everything, all the assets, all the scenes that we have written in C# or Unity, and it's converting them to something that's readable to Xcode. So we have our Xcode open. As you can see, we have the VVR icon. It's indexing all the processing files. This is going to take a little bit before it goes through it. Once here, when you see this is finished, we're gonna select Unity iPhone. We're gonna go into signing and capabilities. Here is where you're gonna require an iOS developer account. For any iOS build, you need to sign it with your developer account. This is true for all iOS devices. So you have to make sure that you have an account that's assigned not only to your Apple ID, but also that you have to get the certain certificates for if you want to submit it to TestFlight. Right now, I'm going to select my account here. So see, we have Unity iPhone Test, and Unity Framework. We're going to select all three here and make sure that we're all signed up. On the bottom, we're going to look for not Unity frameworks, but frameworks here. We're going to open this up. And the key features that we have to kind of make sure that the membership, what I mean by membership, I'll show you in a little bit. When we select, let's say, one of the features that we need to make sure that the membership is for certain devices is security. As you can see, we have a security framework. As you can see, it's only, the target membership is only for Unity Framework. We have to make sure we have it for Unity iPhone. The same for AV Foundation. The same for Foundation. And we also want it for speech. We want to add the framework for Unity Speech here. And once that's done, we can go ahead and hit the build button, and it will go ahead and run it. And then if you're connected to your device, unfortunately right now I'm not connected. Once the build files are done, you hit that triangle. It's gonna run it through. You're gonna get a lot of warnings, no errors. Then once that's done, it'll install on your phone and you'll be able to play it. Give me 1 second. Let me go ahead and show you what it means. So once you have your phone connected, we can go ahead and hit the play button here. Okay, so we need to make sure that we're selecting the iOS device that we're going to build. And then we're going to go ahead and hit play. It's going to compile. It's going to go through all the sourcing. The source files. We're almost done with the compiling and installing it on the iOS device. Just a few more files to go. Although you're not able to see it right now, the device, the application is running on the iOS device. Let me see if I can show you this. This is the output that I was talking about for the Xcode. As you can see certain things that are running. You can go ahead and enable voice, and it'll go ahead and give you all the stack of all the voice commands. The actions that it's executing. You can turn it off, and it turns it off. You can see the on-device recognition result here. Yeah.
Hello, this is Krishna Araujo, and I'll be showing you how to build the Windows version of the app for Unity so that you're ready for development. You should have Unity installed already with Git and Git LFS for large files. You should also download the Unity project from the ChrisDeb branch in the Azure repository. First, I will show you how to build, and it's pretty simple, right? We go to File, we go to our build settings, and we're here. Make sure that the single scene that we have is included, and make sure you're for the PC platform. Then you're gonna build, and here, this is the project as you would see it on Azure. The build folder, it's ignored, right? It's get ignored, so it shouldn't be there. But just create your own folder, call it builds, and build it, right? When it's done, it should look something like this, an executable here. I'm gonna run it, and it should show you the space scene, right? The solar system demo. But if it's not, right, if it's showing you like a white screen, I'm gonna show you how to fix that just now. So what you need to do to fix that problem with the white screen and nothing showing up is that you need to go to your, let me close this. You need to go to where you need to go to resources, and here you have these 5 JSON files, right? We're gonna show in the Explorer, resources, right? We have 5 demo files. So what we are gonna do is select all of them, and just copy them into this directory, right? It's gonna be on your local disk users, then your user as you are in Windows. Go to the app data folder, which is hidden by default, local low, and then here I should change this to FIU, and you could change it in project settings, player, right here. But for now it's just fine. It's just called default company. If you were to change it to some other name, that would be in this place, right? And VVR the project. So I copy those from resources down to here, right? And this is what is known as the persistent data path. There's a link to it on the Unity documents, and basically this is just at the current state, it's a temporary solution, because in the future we want to get these JSON objects over the internet at some point, right? And we would also want to modify our main menu to display the courses or contents that we're signed up for, right, as a student. But anyways, that's for the future. So we have our directory, and now that it's there, you should have everything loaded up, right? And it should show you the space demo. So for now we're good and ready to start development. Menu, let's go to London, I guess. So yeah, that should be able to work. So when it comes to maintenance, there's some stuff that I like to explain about the application. So please beforehand read the README and the documentation, as well as the installation guide, because it will introduce you to each of these classes and the design patterns and ideas behind what we did, right? So quickly I'll show you some pieces of code, and just so you get a general idea of how things work. So we got our JSON files I showed you earlier, right here. And this is just a representation of the graph itself, right? Our content. And each node in a graph has a string that is, it has like a path and then a URL, here, source. This could be like a path or a URL in the future from which we load our content from, right? And here is the node type. It tells you that it's an image 360 type, right? And this next node is also an image 360. And then the last one is a video 361, right? And this is part of the London demo. If you're familiar with that from the previous demonstrations. So if you want to add more types in the future, right, you would find that under scripts on the graph nodes, and these are all the classes relating to the graphs. Here's node data, and all it has is source and a name string. If you want to make more types, they're here. We only have 3 implemented for now. The video one, video 360, image 360, these are the same strings that, what determines what type it is. They're the same. So the one that manages all this graph stuff is the graph controller. And this is a mono behavior, meaning it's active in the scene. And it has like stuff like awake and on destroy, stuff like that available. So here, when it initializes a graph, right, it clears it first, and then it goes through, the reader, the JSON reader, which reads this. And then, since it doesn't know beforehand what kind of node will be used in the graph, right, because it has no way of knowing that, we use something called a node factory, and this is the abstract factory design pattern, right? So whenever I need something, whenever this needs a node of this type, the factory will provide it, right? And the factory will instantiate it and get it ready. And then, the graph controller would just add it to the graph, right? And then do the stuff with the edges, because that's also part of the information in the JSON file, right? It tells what do I connect it with. So back in the graph controller, it does this, and then later on, right, when we want to change our current node, when we do the whole move thing and then select a waypoint, and that waypoint represents a different node. Here, we are talking to the state machines, and what it does is it changes the type, right? So let's say we are on a, it should be over here. Yeah, okay, here. Let's say all graph controller did was, talk to the state machine, and whatever state it is, depending on the type, we're gonna act differently, right? So here's an image video type, and when it gets, let's say we're on an image 360 node, and then we want to go to another image 360 node. Here I would say, oh, I'm going to this one. I'm already in an image content node and nothing happens, right? But let's say I'm in an image 360 node, and then I want to move to a video 360 node. Then this happens. The state changes. We go to a video content state, and when we enter, we enable the video player and then load whatever video we needed to load, right? We're loading our clip from source. And whenever we enter an image node, we disable the video player, and then we just load the material, the texture that we needed to. So that's basically how our graph system works. And it interacts with the state machine and all of that. And if you wanted to add more node types, you could just make a child of the node data type, right? And each node has that, right? Each node has, if you see here, it has a node data value, and that's what determines its string ID, I guess. Another big part of the application is the event system, right? And it's handled with scriptable objects. And all they do is they wrap around a Unity action. And you can see it inherits from scriptable object. So this one that I'm showing right here, it takes an integer. And this one just takes a vector 3 position, and this one doesn't take anything, I think. Yeah. And we create different ones based on what we need, right? This one takes in a string. If you want to create a new one, because these are scriptable objects and you can do that, you could create these assets, right? Let's say, and there's only 4 because there's 4 types. So let's say we want to make this, and we have a new asset. Now what do we do with these assets? I'm going to delete it because I don't really need it. You could find these assets under scripts, scriptable objects, right? And here we have them, and each one of them is like in a way like a channel, right? For an event, you need someone in the program to notify, to run the action, and you need other scripts, one or more, to listen to it, right? So here's the simplest example I have is the UI node manager, which is in charge of displaying the waypoints and selecting one, and telling the graph controller, hey, we moved to this specific position. So here you can see it has a move event, right? And that's already an asset right here, and it's based on one of our 4 scriptable object types, right? So it's here, has a reference to it. Let's check it out. You can see it here, move event. And you know, when it awakes, we register it along with the other ones that it also listens to, because it's doing other things as well, right? So this is the listener. And you know, when we awake, we register, and then we register this method right here on the band heard. And what it does, it activates the waypoints, right? And that's the logic for that. But who gets to call that? Now this same, it's pointing at this, right? At this one. The same thing is being called by this one, right? They're sharing the same asset, and that means that one listens and the other one notifies. So let's go check this one out. In racecast the SAM, you see here's the move event, and he's passing it down to this state, to the move state. So we're gonna go to that state. Here's the move event. It's been passed into it when we initiated it. And then you see that whenever we get a command, depending on the command, it will do different things. So this is when we are already in the move state, right? So when we enter the move state, we raise the event. This is what calls it. This calls it, raise the event, and then UI node manager realizes that and calls on event heard, and then it activates all the waypoints as needed, right? It checks all the current neighbors and puts a waypoint in that position. So yeah, and there's a lot of stuff throughout the game, right, that deals with different commands, right? This one's listening to something else. And, you know, I could also mention that we have this asset. It's the only paid asset that we paid for, is the menu, right? And this one object is the one that deals with showing the 4 demos, right? Here's the one for London, the solar system, the hospital, and the fantasy one, right? And each one of them has a thing. And this also has like an event, right? But this is the launcher. And in this case, there's like 3 different things that listen to it, you know, because I think one of them is graph controller, right? He has to reset the graph and then create, you know, the one based on the different JSON file that we load, right? So, you know, getting familiar with how the scriptable objects event system works it's going to be important for whatever future functionality you want to add, you know, or you could just revamp the system. It really is up to you. So earlier in the video, Aussie showed you how to add more voice commands, right, to interpret commands dictionary. On the Windows version, I have this script that, you know, it also deals with interpret command. And, you know, in this case, we use Windows voice control because, you know, it uses Unity's built-in Windows voice recognizer package. And in this case, we have this, and we're adding to the interpreter dictionary, right? The dictionary takes in as a key, it takes in like a, you know, a string with a command, and then it returns an action, right? And here we have it as a lambda function. So all it really does is talk to the state machine, the one it needs to talk to, right? Because you see menu interacts with both state machines, but the commands for, you know, moving and all of that only interacts with one state. So let's say we go to, you know, again, we're going to check this example, right, with the move raycast state. You know, all it's doing, it's asking the state machine, are we, depending on the context that we're on right now, does this command make sense? Is this command available, right? So we go into the move raycast state, and this is when we are already inside move. And here, you know, go is available, but on the select one, there's no go, right? Because it's not within the context. So if it doesn't understand it, it will just go to default and not do anything. And the same thing goes here, right? You know how select you could do touch to talk to the interactables? Well, in the move raycast state, you don't have that. And this is what allows us to do the context sensitive commands, right? So in the case of move, it says go. Well, let's say we want to go into the menu while we're in the middle of the move state, then this will, change it, and then it would cancel the move state command by deactivating the waypoints. So, this is how you connect things together, right? What you want to change, from one state to another, depending on the kind of command that you used, either to do something or to cancel it, right? The state command, that's only available when you're in the move state, when you're already in the move state. And what the state command does, it just goes back to the empty state, when you're not doing anything. And it raises the events again so that you could, deactivate the waypoints. So yeah, that's just that's where our context sensitive stuff comes from. If you want to add more commands, you add them to you first add them to the interpret command, right? And then you would have to create within the states, right? You would have to make some way for it to actually detect, right? And to do something based on that. And that's when the context comes from. Hopefully that explains some things about how the project works in the background, right? So thank you.